Okay, so here, Chapter 2, Section 2, going to talk about elements, compounds, molecules. And so, as you know, atoms really don't like to be alone. They like to get together with other atoms and form molecules. And so, sometimes, of course, they get together with an atom that's just like them, and other times they get together with ones that are different. And so all of these are molecules, but these guys are the compounds. They're the ones that are composed of two or more different elements. That's what makes a compound. Whereas these guys here are just molecules that are basically just pure elements. Okay. They don't have other elements, just chlorine, nitrogen, oxygen, hydrogen. Typically, ones that are pure elements, well, maybe I shouldn't say that. They often are kind of these small molecules, although there are things like carbon, for example, can form large masses of relatively pure carbon. But these guys show a bit more complexity, obviously, because they have different types of atoms. Okay, so what's holding these atoms together? Well, that's chemical bonds. And so, as we know, there are several types of chemical bonds, and there are ones that are bonds that basically hold the atoms of molecules together, so they're within the molecule. And so we know that as covalent and ionic bonds. And then there are some that hold different molecules together. They're between molecules, intermolecular. And that's what we call the hydrogen bonds. All right, so let's look at those. So ionic bonds. Ionic bonds form when two atoms get together and one, in this case chlorine, takes an electron from the other one, in this case sodium. So sodium chloride, or salt, is the sort of classic type of ionic compound, because when the two atoms get together, you form a negative and a positive ion, and it's the opposite charges that hold it together. Notice here that with chlorine, it has 1, 2, 3, 4, 5, 6, 7 electrons in its outer orbital. It would like to have one more to be happy. Sodium just has one. So chlorine really wants to get that extra electron, and so it takes it from sodium. Sodium only has that one lonely electron in its outer orbital, so it's willing to give it up, because now it has 8 in its outer orbital, and chlorine has 8, so they're both happy. They have formed ions, and they bond together. All right, covalent. Now with covalent, instead of those electrons, instead of an electron being taken, it's now being shared. So you recall hydrogen has an atomic number of 1, so each hydrogen atom has 1 electron. Well, here, these two hydrogen atoms are sharing these pair of electrons. So the pair of electrons basically are spending time on each atom. And so at any given moment in time, this guy might have 2, this guy might have 2, and so the two atoms are happy. They have formed a covalent bond. Same with oxygen. Now oxygen is a little different. You notice we have a double line here. It's sharing 2 pairs of electrons, and now each one is happy. You'll remember that oxygen has an atomic number of 8, which means its outer orbital has 6, and so it would like to have 2 more. All right, so here's a compound. So we've got CH4, otherwise known as methane. And so carbon with an atomic number of, did I say 6 for oxygen? I meant to say 8. Oxygen has an atomic number of 8, 2 on the inside and then 6. Carbon has an atomic number of 6, and so it has 2 on the inner orbital and then 4. And so it wants to form 4 bonds, so it will bond with 4 other atoms, quite often. including with these 4 hydrogens to make methane. They're each sharing a pair of electrons here, pair of electrons here, here, and here. And so now each of those atoms has all it needs. All right, now hydrogen bonding is not within, but between molecules. And so, as we've talked about, and we'll talk about more when we talk about water, is that oxygen, as we know, is a bit when it gets together with something like hydrogen, it's sharing a pair of electrons, but the electrons spend more time on oxygen because oxygen is relatively electronegative, which means it tends to not quite share those electrons so much. They're sharing, but they spend more time on the oxygen. So because the electrons are spending more time here, the oxygen has a negative charge, and the hydrogens have a positive charge. So we describe this as a polar molecule with polar covalent bonds. Okay. And so when you have a bunch of water molecules together, they will form these hydrogen bonds where the negative side of one bonds with the positive side of the other, and it does that all over the place. Now, you'll notice there's no bond between these guys here. Well, at least at this moment in time there's not, but at another moment in time it might form here and break here. So these bonds can quickly break and form. And that is why water in its, H2O in its liquid state flows and moves, because the molecules are sort of moving around each other. Now, once water starts to freeze, as we'll talk about later, that's when those hydrogen bonds kind of start getting locked in place and the molecules are no longer moving all that much. Okay, that's section 2.